Hey everybody, I'm Rob. I'm an iOS engineer at Blue Apron. Really excited to be here at DevCampDC 2017. Now I know this is iOS DevCamp, but today I'm actually going to kind of get outside that box a little, and I'll bring it back. But I'm going to be talking about the Internet of Things and some awesome stuff we can do. So background is that I was working on a little hobby project, kind of built on a whim, and it touches on a broad range of topics, and I'm going to kind of dive a little bit deeper into each one. But my goal is that by the end, I just want to make your concept of full stack a little bit deeper. So here's just a short summary. There's a lot of material to cover, but I'll post the slides after, so don't worry about trying to copy anything down. I'm going to ease in with kind of a high-level discussion of what I think Internet of Things is and what it means for us. And then I'll start in with I'll jump right into a demo, and this is the project that I worked on. From there, I'll go over the hardware and software concepts that I used to build this project, and we can start executing. And then after that, I'll leave a jumping off point. I'm going to talk about what's next. What does this mean for you? What are some future projects you could work on using these concepts? So yeah, Internet of Things, terminology. What does that mean? I think we hear this a lot, Internet of Things. And I just want to kind of say or discuss what this means to me and why we should care as mobile developers. So first thing I do, I go on Google. This is the first image that comes up. It's like an amorphous blob of technology. This is the Internet of Things. Computers and phones, we know, of course, we all know and love them, but there's a factory, there's a thermometer, some kind of a light bulb. My question is, what is the goal here? It kind of looks like Internet of Things is just a bunch of stuff with Wi-Fi, but I just want to say it's not just a bunch of stuff with Wi-Fi, that you can make awesome interactions, and I'll show you how. So getting a little bit more concrete, there are these light bulbs, Philips Hue light bulbs. So these are just light bulbs that you replace existing light bulbs in your house with these. You can kind of control them. Excuse me. They replace conventional bulbs. And then while you're setting them up, you have to kind of plug in this weird box thing. And then you can use your app to control their color and power state. So just at a high level, there's the thing, and then there's a bridge, and then there's this kind of internet and app world that we all know and love. So I think this is just kind of the pattern to keep in mind when you're talking about the Internet of Things. It's kind of a metaphor. And it seems pretty simple, but I think it's important, is that basically IoT is all about building the bridge between kind of the physical everyday objects world and the internet, the app world, the stuff we work on every day. So yeah, we kind of understand what those two worlds are, but what does it mean to build a bridge? Well, today, what I'm actually going to be talking about is how we build our own bridge for the Internet of Things, how we connect our own objects to our own apps. And really, like, this should be the real title of the talk. I didn't want to get any civil engineers excited, but we're at iOS DevCamp, though, so why do we care? Well, I think key takeaway is everybody is interacting with the world through their phones these days, so the Internet of Things is no exception. The bridges that you're going to be building are between phones and the physical world, not computers. So the other end of that bridge is mobile. This is great for us, though, because as we all know, mobile is awesome, and there's so much awesome to be had on mobile, and we have a deep relationship with the user. So I think IoT is very much a mobile technology. And then more specifically, as iOS developers, there's something for us here, too. We can do this all in Swift, believe it or not. And it's really great to be able to use a language that you know and love for something that's new and exciting. But still, what are things? I've kind of been hand-waving away. What are things? So it's really all about interfacing with electronics at some level. Most modern everyday objects have control circuits. They're controlled via electronics, and we just need to find a way to kind of get on their level. You could get really advanced with this. Obviously, electrical engineering is a whole field in of itself. It's an enormous universe, but I don't think we need to go that deep because most things can be modeled using just simple circuits, and you can get pretty far with those kind of concepts in mind here. Of course, don't go disassembling your toaster on my advice. Not just yet. So I'm just going to bring up a kind of simple circuit here. This is kind of metaphor I'll use as we talk about the Internet of Things. Really simple. It's just got a power source. It's got a button, and it's got a light. When you push the button, the light lights up. Really, most things are not more complicated than this. You turn on a light, you turn on a coffee maker, and there are easy ways to kind of connect to these types of circuits. So this is kind of the simple metaphor that we'll use. So that was just kind of a really high level setting the stage for what Internet of Things means to us. Now, without further ado, I told you that my doorbell runs Swift. Let me show you what that means. This is kind of going to be like a cooking show where I show you that finished pot roast, and then I show you all the hard cooking you actually need to do. So without further ado, this is what it means for my doorbell to run Swift. Guest is woken up stairs. Great video. They push the doorbell. Some wires. Mysterious bridge. Now here's the magic. So I get a push notification on my phone. And I have an open door function on that push notification. Got to authenticate. But just like that, I can just get in. So that was a very high production quality video. Thank you. It's actually really fun to make those. So that's my doorbell running Swift. So what does that mean? Well, the key takeaway I really want to draw out of this is that this is a super simple interaction that a lot of us have every day, or, well, depending how many guests you have. But there's lots of those kind of interactions in the world. So I'm going to be talking about my doorbell, but try to think of it in a more general sense. If you can do something simple like simulate pressing a button or simulate detecting whether your doorbell is ringing, you can do a lot of things. So keep your mind open and see how this applies to something some pain point that you might want to solve, some project you might want to work on. So that was the demo. Now let's just talk a little bit about hardware. This is interesting because in the Apple world, we're not really used to talking about hardware all that much. Like, we've been taught that there's kind of a closed world here. It's a closed system. Apple's already given us all the hardware we'll ever need to worry about. That's true for the most part. Certainly, there's no lack of diversity in device classes, but The issue is actually that like these devices don't quite capture exactly what we need to build that bridge in between the internet and real things. And we'll get into why. So to understand why, just ask a basic question, like what do we actually need to build this bridge? Well, A, we need to talk to the internet, obviously. We need to talk to real things, whatever that means. And at the end of the day, I mean, our bridge is basically just going to sit there, so it'd be cool if it was non-mobile, kind of install it somewhere. Well, iOS devices are too mobile. They're in our pocket all the time. We're not going to hook them up to our doorbell. Something like a Mac or an Apple TV, like that comes closer, but there's kind of a sticking point here. How do I hook a Mac or an Apple TV up to my doorbell? I don't have a USB port on my doorbell. They're all lacking a way to interact with simple electronic circuits at a low level. So what do we use? Well, we actually have to leave the Apple store to find this hardware, which is sad. It turns out that there's a device that checks all of our boxes, and it only costs $35. It's called the Raspberry Pi. Some of you might have heard of this already. It's this tiny computer with an efficient ARM processor like your iPhone. It's so small, it's practically the size of a credit card. You can mount it virtually anywhere you want, which is naturally amazing if you're trying to build a device that connects to real things. It runs Linux, also similar to an iPhone, so it gives you access to a wealth of software, including critically Swift, the Swift compiler. Of course, it has both Wi-Fi and Ethernet, so internet connectivity is not going to be a problem for us. But the feature that really is exciting about the Raspberry Pi is this thing that we call general purpose input and output, or GPIO. So what is GPIO? I like to call it an API for electricity at a really high level. If you're holding your Raspberry Pi, it's this port on the edge that kind of looks like a series of pins. GPIO allows you to interact with circuits at the lowest level possible. So that means you can do things like turn a light on and off or read the value from a sensor. With relatively small effort, you can design circuits that interact with these everyday household objects. So there's a great quote on the Raspberry Pi documentation. At the simplest level, you can think of a GPIO pin as a switch that either you can turn on and off for input to the Raspberry Pi, or that the Pi itself can turn on or off for output. So just to kind of dive in and illustrate, this is what it kind of looks like to set up a GPIO pin as an output. Say I have just a light hooked up to that pin. As my program executes, I can set the value of the pin to either 1 or 0. This turns the light on and off respectively. One more thing. This could also be referred to as high and low in the kind of electrical terminology. So high is on, low is off. If you see that around, don't be alarmed. We can also set up the pin as an input. So if we think about our button from earlier, if we push the button, the pin will have a value of 1. And when we release the button, the pin will have a value of 0. And as our program executes, we can check that value and do something with it. So this really kind of just captures how uniquely situated the Raspberry Pi is, because it has Swift, it has Wi-Fi, and it has GPIO. Raspberry Pi is the perfect bridge because it can sit right in the middle of these two worlds, and it has all the interfaces we need to connect to both of them. So Raspberry Pis are amazing. Everybody go buy one. That's what our bridge hardware looks like. Let's move on to the software. So we bought our Raspberry Pi. There's still a little bit of setup that we need to do. Sadly, this isn't quite as turnkey as iOS, which is famously simple. We have to install a version of Linux. We have to install the open source Swift toolchain, which, as an aside, it's amazing that Swift works on Linux. That enables this entire project. Major props. There's a few dependencies here and there that you need to install. It's pretty simple, but I put a guide up on my website that you could just run through to set up your very own Pi. Check it out and reach out if you have any issues setting up your Pi. Maybe one day we'll have PiOS. So now we're all configured. Let's start building the software stack for our bridge. I've broken it down into kind of two main categories of software that I like to think of. The first category is what I would call interacting with things. And this is where I use the library SwiftyGPIO to interact with those GPIO pins. The second I'll call interacting with the internet. This is where I'm going to stand up a web server to expose an API and send push notifications. And again, to stress it, putting these two worlds together is what enables this powerful interaction. So returning to a topic that near and dear to my heart, SwiftyGPIO. So we know that this is a way that we can interact with simple circuits. SwiftyGPIO is a Swift library that enables you to control that from Swift. Because it's all in Swift, it integrates great with other Swift libraries. So let's see what that code actually looks like. Pretty simple. You initialize a GPIO object using the type of device that you have, Raspberry Pi 3, and what pin number your circuit is connected to. From there, it kind of forks depending on whether you want an input functionality or output. If it's an output, you set the direction to out, and from there, you can change the property, you can change the value of the value property. If it's an input, you set the direction to in, and you're going to read the value from the pin. So going back to our light example, we see that this is kind of how we turn it on and off in code. As your program executes, time passes. It's this simple. You just set the value of the pin. And then if we go back to our button example, we see that we can also read the value of the pin depending on whether the button is pressed or released. But, well, what if we wanted to do something when the pin changed value? Well, you could set up a simple polling cycle, just constantly check the value of the pin, but doesn't seem very efficient. It would be great if there was a better way. Well, it turns out there is a better way. So if we look at the logic diagram, which is this line here that just represents the value of the pin, it's pretty obvious to us when something happens that we care about. It's just a vertical line. And these are called edges. When the value is going from 0 to 1, it's called a rising edge. And when it's going from 1 to 0, it's called a falling edge. And this is important because GPIO hardware actually can handle these cases specially and give you an event when an edge happens. So SwiftyGPIO exposes that functionality by giving you a number of handler blocks that you can register for on your input pin. So each time your pin's value either raises or falls, you'll get a raising or falling callback. There's also a general on-change handler. This is called back anytime the value changes. Maybe you don't care whether it's raising or falling. So now our code is super concise, and we can respond to a button press really quickly. Next, we want to do something with this interaction. So let's talk about server-side Swift for Internet of Things. Moving up the stack a bit. So writing a web server in Swift is a pretty hot topic right now. We know it's especially great for iOS developers because you use Swift, you can share code between your backend and your mobile app. There's a lot to say about server-side Swift, but the things we actually care about for Internet of Things are a little bit smaller. So I'm not going to dive too deep into it. One thing to note is that we're kind of a special case here in that we're running Swift on a Raspberry Pi, which is an ARM processor, and it's Linux. So sometimes it's not exactly a turnkey solution to just use whatever framework's out there. Good news is that Vapor, which is a popular framework, works well on Raspberry Pi. So that's what we're going to use. Like I said, I'm not going to dive deep into what server-side Swift means and how to implement it, but I'm going to talk about kind of what this means for Internet of Things and how we design this API, because that's kind of what's universal no matter what framework you use. So it's a pretty simple interface because it essentially maps to the things you want to control in your electrical interface. So for example, if we have a light, maybe we have a post endpoint to toggle that LED. If you have sensors to read, you can just use a simple get endpoint to return the value. But again, this sounds somewhat familiar. Remember how we didn't want to keep polling the input pin to check whether the value had changed? Well, similarly, we wouldn't want to poll an API to check when the value of the button state endpoint had changed, certainly. So we're going to handle that doorbell sensing in a different way. We can actually use push notifications to provide a similar event-driven model for that interaction. So push notifications, we all know, they allow our app to receive information when it's not running asynchronously. Might be familiar with push notifications and receiving them from a client app, but today we're actually going to send them from a Raspberry Pi, from the server side. Luckily, it's actually not too difficult to do this. There's a great library, Vapor APNS, that allows this. So let's just go through it at a high level. There's three main steps. First, naturally, we need to ask our users if they want to receive our notifications. Hopefully they do, because you are the user of your doorbell. And then once you successfully register for push notifications, you're going to get that device token back. You're just going to send that up to your bridge, your Raspberry Pi, and save it there. And then when something happens, whatever your event that is interesting happens, you just submit the push payload to APNS to actually send the push notification. So here's just a little bit of sample code. We're here in the iOS client. We're asking for authorization to send push notifications, notably using the new UN User Notification Center APIs. We're requesting authorization to present an alert. This also applies to a banner. If we're granted, we can tell our application to register for remote notifications. And then here we get this callback application did register for remote notifications with device token. And this is where we actually get a data object that contains the device token for your device. This is device specific. This is what enables Apple's push system to actually push that message to your particular phone. One thing to note, you might get this callback more than once. It's not necessarily true that you're only going to have one device token for each device that you register, and it's not a one-to-one mapping of saying that you want to register for device tokens to get a device token. Sometimes it changes just opaque to you. So anytime you get this callback in your app delegate, just send up that new device token to make sure you can continue receiving notifications. So yeah, this is just a simple data task. Now here we're on the Raspberry Pi. After the bridge saves that token, we can use it to actually send a push payload. So here I'm sending a really simple message, ding dong. And of course there are other parameters you could add to the payload if you want to make it much more full-featured. And success. So this is all it takes to send a push notification from a Raspberry Pi, which I thought was neat because being an iOS developer, there's kind of this black box around push notifications, but it turns out it's pretty easy to do. So that's kind of just why I wanted to walk through the general flow of it. Of course, there's some setup and provisioning you need to do in order to actually get to the point of sending push notifications, but we're used to that. So let's just go over the software. It's kind of a whirlwind. At the lowest level, we have SwiftyGPIO running our GPIO pins and giving us this interface to things. As the backbone of our bridge, we used Vapor to build a web API. And then on top of Vapor, we use push notifications to actually push event-driven communications. And this all interacts just with our client app that we build for iOS. So I'll kind of recap on the project that I demoed to you earlier. It's been a long road, but now I'm actually going to talk about how I implemented this specifically. So let's go back to this great video and just tease apart what's actually happening here. So first off, someone pushes my doorbell. Great. So my Raspberry Pi running my bridge software sends that push notification. I get it on my phone. I execute the quick action to open the door. It comes back to the Pi, and the door actually opens. So again, pretty simple interaction. Let's kind of go into how I actually built that. So the kind of first step that I started with was laying out what I actually needed to interface with on the electrical side. So for each function that I want to control, I'm going to need to allocate a GPIO pin. It's going to need to be either an input or an output. And then for each of those functions, what does it mean for that function to be on? What does it mean for it to be off? So starting with door open, this is kind of the function that simulates me pressing the door open button on my doorbell. So I'm connecting this to pin 2 because for some reason the Raspberry Pi's GPIO pins start at 2. So I don't make the rules. But yeah, it's an output. And the on state is going to be simulating me pushing the button. And the off state is just the door is still being locked. I'm resting. Nobody's pushing the button. The other one is something that I'll call bell detector. So this is the simple circuit that detects if my doorbell is ringing. And I made this simple circuit to just kind of map that event to the on-off state that my Raspberry Pi is going to expect. This way I can just hook it into the GPIO just like any other sensor, like a button. So that's going to be an input on pin 3. When pin 3 goes high, when it turns on, that means my doorbell is ringing. And when it's off, it's just quiet. So this kind of ties everything together. If we go back to like our 4 steps up top, first the doorbell rings. Our bell sensor circuit, what that looks like from a GPIO perspective is that it becomes 1 for some period of time, and then it goes back down to 0. So we can use the GPIO rising edge functionality to just listen for that event and send our push notification. Then you're running the client app on your phone, you're receiving that push notification. The third step is the user pressing the door open functionality. And that's a simple API request to just post to the door open endpoint. And then the bridge can execute that actual door open process. And what that looks like from the GPIO perspective is just bringing the output, the door open output, to 1 for some period of time and then back down to 0. Again, simulating that I'm pressing a button. So you can see it's kind of a lot of disparate components, but when you kind of tie them all together, it enables a really cool interaction. So that was the software that's running on my Internet of Things bridge, and also a more specific peek into what it means for my doorbell to run Swift. The next question is, well, where does that leave you? What's next? Well, like I said before, these tools are just frameworks for building a whole number of different projects that you could use. Rising edges can trigger any number of different interactions, and you can kind of hook this up to anything, you know? So here's some great future project ideas. I was just spitballing the other day, and so I picked the first 3 thoughts that came into my head. So here it comes. I can put a button under a mat next to my bed, and when I step on it in the morning, send a push notification with the weather. You could hook a sensor up to your toothbrush cup, measure the amount of time you spend brushing, and shame yourself on Twitter if it's not long enough. You could also detect some motion near your cat's litter box and be alerted if your attention is needed, because I'm sure you would all sign up for those notifications. So the idea here is that all of these projects are really simple. It's basically just a button. You just need something to hook the button up to with internet connectivity and the ability to send push notifications. So the world is your oyster. Another thing that's actually really exciting, so we've all heard of HomeKit. If you haven't, HomeKit is Apple's answer to kind of the Internet of Things. So HomeKit devices are really well integrated into iOS. They could be lights, they could be door locks, there's all kinds of device classes. And you as a developer, a client app developer, you can interact with HomeKit devices because the creators of HomeKit devices adhere to the HomeKit standard. And because it's a standard, you can actually interact with those devices in an expected way. Now, up until recently, you could be a developer and you can interact with HomeKit devices, but it wasn't really easy to create HomeKit devices. At WWDC this year, Apple kind of threw us a nice surprise by announcing what they called the non-commercial version of the HomeKit accessory protocol. And what this means for you is that you now don't need to be a huge Fortune 500 company with a manufacturing partner to make a HomeKit device. Now you, with a Raspberry Pi, can make a HomeKit device that can actually participate in the HomeKit ecosystem. What this looks at a slightly lower level is that the actual authentication for HomeKit can now all be implemented in software, whereas before you used to have to install a special Apple-designed chip in order to be a HomeKit device. now you can do all of that authentication and handshaking directly in software. So that's really exciting. Unfortunately, I didn't get the chance to actually implement this yet, but I know what I'm going to do next. And of course, these could also be implemented on a Raspberry Pi bridge. Other thing to think about is, like I said before, other developers can interact with your HomeKit devices. So if you participate in the HomeKit ecosystem, it opens up an entire world. So that about wraps up my talk on the Internet of Things and Swift and Raspberry Pi. I hope you enjoyed it. I hope it wasn't too confusing. Thanks so much. If you have any thoughts, feel free to reach out. I'm on Twitter, of course. Thank you so much to iOSDevCampDC. I hope you have a great rest of the conference.